Welcome to my YouTube channel. I am Vasant Naik from Government First Grade College, Kumta. This video is prepared for BSc third semester of Karnataka University, Harvard. In this video, I am going to explain you how to derive the expression for focal length of a thick lens. Let us consider a spherical surface of radius of curvature R1 is the pole of the first spherical surface, is the second spherical surface of radius of curvature R2. This is the pole of the second spherical surface. Small letter t is the thickness of the lens, and the principal axis which is passing through the pole of the spherical surfaces. Now AB is the incident light. It is incident at a height h1 above the principal axis, and BC is the refracted light from the first spherical surface, and that is the incident at a height h2 above the principal axis. After refraction from the second spherical surface, it meets the principal axis at f2. Suppose in the absence of the second spherical surface, the light ray BC travels without any deviation and it reaches the principal axis at point I. Remember, in the absence of the second spherical surface, the BC light ray travels without any deviation and it reaches the principal axis at the point I, and F2 is the second focal point, and this is the second focal plane which is passing through the F2 and perpendicular to principal axis. Extrapolate the AB in the forward direction and F2D in the backward direction. They meet at the point H2. At the point H2, you have to draw a plane passing through H2 and perpendicular to principal axis. It meets the principal axis at P2. P2 is the second principal point, and distance between P2 and F2 is the focal length of the thick lens. Here PC dash is the incident light and refracted along C dash B dash, and B dash A dash is the refracted light from the second spherical surface. Here F1 is the first focal point, and at the first focal point F1, I have to draw the plane. So this is the first focal plane, and now to extrapolate A dash B dash in the backward direction and PC dash in the forward direction. They meet at the point H1. At point H1, I have to draw a plane, the second principal plane. And that second principal plane cuts the principal axis at point P1. It's called first principal point. And the distance between P1 and F1 is the focal length of the thick lens. Therefore, in order to derive the expression for focal length of a thick lens, in 2 paragraphs we have to explain this diagram, and let us derive the expression now. For that, I have to take a first surface of radius of curvature R1 and second surface of radius of curvature R2 of poles A and D respectively, and AB is the incident light at a height h1 and BC is the refracted light from the first surface, and in the absence of the second spherical surface. The light ray travels without any deviation and it reaches the principal axis at point I. Therefore, here you have to think that there is the absence of the second spherical surface. You have to first derive the expression for first spherical surface. In the absence of the second spherical surface, the BC light ray travels without any deviation. Therefore, you get the image. Now, this is the parallel rays of light. The light is traveling from the object which is at infinity and we get the image at I due to the first spherical surface. Therefore, the refraction formula for a single surface there is for a first surface is given by n by v minus 1 by u is equals to n minus 1 divided by r. Now to substitute the value, that is at the first surface you are getting the parallel beam of light, therefore object is at infinity, therefore object distance is equals to infinity, therefore image you are getting at point I1 with the first surface, therefore the distance EI is the image distance for the first surface, therefore image distance is EI and radius of curvature of the first spherical surface is R1. Now the equation becomes n divided by v is ei here, 1 minus u is infinity equals to n minus 1, radius of curvature is r1. Therefore, the equation becomes n by ei minus 1 by infinity is equals to n minus 1 divided by r1. Then the equation 1 by infinity is 0, therefore n by ei is equals to n minus 1 divided by r1. Dividing the equation by n, we get 1 by ei is equals to n minus 1 divided by n r1. Because we have to divide this equation by n. Here n get cancelled, here 1 by ei, therefore n minus 1 divided by n r1. This is the equation number 1. Now look at the diagram here. In the if the PC is the refracted light from the first surface, which is incident on the second surface, then it refracts because the BC is incident at a height h2 above the principal axis. After refraction from the second surface, it meets the principal axis at point F2. It is the second focal point, and to extrapolate the BC, AB in the forward direction, F2C in the backward direction, they meet at the point H2. At point H2, you have to draw the second principal plane and you get a second principal point. And here distance between P2 F2 is F. Now, you have to consider the second spherical surface. You have to write the refraction formula for the second spherical surface. For that, here I is nothing but the image formed by the first spherical surface. That image formed by the first spherical surface acts as the object for the second spherical surface. Remember, I is the image formed by the first spherical surface. That image formed by the first surface acts as a object for the second spherical surface. Now this is the object I for the second spherical surface. Therefore, object distance is dI. Because this is not a real one, it's a virtual one. And F2 is the image formed by the second spherical surface. Therefore, dF2 is the image distance. Now write the refraction formula for the second spherical surface here. Is you have to substitute the value object distance as dI, image distance as dF2, spherical surface, radius of curvature of the second spherical surface is R2, and substitute the value here. Refraction formula becomes 1 by n divided by dF2, that's the object distance here. We image distance dF2 minus 1 by di is equals to 1 by n minus 1 divided by R2. Now rewrite the term as 1 by n dF2 minus 1 by di. this equation becomes 1 minus n divided by nr2. Therefore, the equation becomes 1 by df2 minus n di. That is, you have to multiply this equation by n. Here n get cancelled, here minus n divided by di. Here n get cancelled, therefore 1 minus n divided by r2. Therefore, here 1 by df2 is equals to n by di plus 1 minus n divided by r2. Yeah, this is 1 by df2 is equals to n by di plus 1 minus n divided by r2. That is takes as equation number 2. You have to remember these two equations. Now from the triangle x2 p2 f2, you see here the triangle x2 p2 f2 and cd f2, these are the two similar triangles, and also BEI and CDI are two similar triangles. First one is H2P2 F2 CD F2. Second one is BEI and CDI. Therefore, here the ratio of the H1 by H2 is equals to P2 F2 divided by DF2. That is, in this triangle H2 P2 F2 and CDF2, the ratio, this H2 P2 is nothing but H1. Therefore, the H1 by H2 is equals to P2 F2 by DF2. In the triangle BEI and CDI, the ratio of BE by CD, it is H1 by H2. Again, it is H1 by H2. H1 by H2 is equals to EI divided by DI. So in this triangle BEI and CDI, this is the ratio of EI by DI. Therefore, this is the equation from these two similar triangles, and from this triangle, similar triangles, H1 by H2 is equals to EI by DI. And therefore, the equation for 1 by df2 is equals to, here, this is equation of 1 by df2 is equals to EI by DI into 1 by P2F2. But we know that P2F2 is the nothing but the focal length of the thick lens. To substitute the value here, therefore the equation becomes 1 by df2 is equals to EI by DI into 1 by f. This is the equation number 3. Now, from equations 2 and 3, this is the equation 2 and equation 3. Already we have derived the expression for these in the previous slides. Now, both the equations are for 1 by df2. Therefore, let us write these equations for n by di plus 1 minus n r2, that's equals to ei by di into 1 by if f. That is, equation 2 is equals to equation 3, and now 1 by f is equals to, have to multiply this whole equation with di by ei. Yeah? Now to multiply this equation with di by ei, here n di by multiply with di by ei plus 1 minus n r2 into di by ei. Here di and di get cancelled, and here the equation becomes 1 by f is equals to n by ei plus 1 minus n r2 into di by ei. Now, according to this diagram, you know that the distance ei, this di, you can write di as ei minus ed. Remember, it is di is equals to ei minus ed. Now the ei di is equals to ei minus ed is nothing but e to d is thickness of the lens. Therefore, di is equals to ei minus t. Now substitute the value of equation 1. This is the equation 1 we have derived in our previous slide. So substitute the value of equation 1 and also the value of di. That is, you have to substitute the value of di and substitute the value of ei from the 1 by ei from the equation 1. Now this equation becomes 1 by f equals to n by ei 1 minus n r2 into di by ei. That is, the value of di is ei minus et. I have substitute the value here. Substitute the value of di as ei minus t. Now substitute the value of equation 1. 1 by ei is n minus 1 divided by nr1 plus, and here that equation becomes ei and ei get cancelled minus t by ei here. Therefore, this equation becomes 1 minus t by ei. Yeah, this is 1 minus t by ei. Therefore, n, substitute the value of 1 by ei is n minus 1 divided by nr1 plus 1 minus n divided by r2 into 1 minus e to 1 by ei value is n minus 1 divided by nr1. This is the equation number 4. Now, this 1 by f is equals to n minus 1 and r1 is in the this equation, equation number 4, n get cancelled. This equation becomes n minus 1 divided by r1, and you have to multiply 1 minus n divided by r2 with into 1. Therefore, here you get 1 minus n divided by r2 minus p into n minus 1 into 1 minus n divided by n r1 r2. We have to multiply here. Therefore, the equation becomes n minus 1 divided by r1 plus 1 minus n r2 minus 1 minus n divided by r2 into p into n minus 1 divided by n r1. So therefore here have to write 1 minus n as n minus 1. Therefore, all the equations you have to write as it is, n minus 1 divided by n r1. Here, you have to write instead of 1 minus n, you have to write n minus 1. It becomes negative. Therefore, minus n minus 1 divided by r2. Here, the plus. Instead of 1 minus n, you have to write it as minus n minus 1. Therefore, this equation becomes plus. Therefore, it is plus n minus 1 divided by r2 into t into n minus 1 divided by nr1. N minus 1, you can take it as a common, therefore 1 by f is equals to n minus 1. N minus 1 is common, therefore you get 1 by r1 minus 1 by r2 plus t into n minus 1, because 1 n minus 1 is common, but you get another n minus 1 here, 40 into n minus 1 divided by n r1 r2. So this is the expression for focal length of a thick lens of refractive index n and radii of curvatures r1 and r2, and p is the thickness of the lens. Thanks for watching.